Okay, welcome this morning. This is our Math 1113, 8 a.m. Zoom meeting. Did you want to start with your question?
Sure, yeah. It's over the personal study plan 5.3.
Okay. Do you want to feed it to me?
Yeah, it says write the first trigon trigonometric function in terms of the second for theta in given quadrant. And it just says sec of theta, tan of theta, and then it says that's going to theta in quadrant 3. I can share
Okay,
my screen if you want.
quadrant 3. This is off WebAssign.
Yeah, question 3 on 5.3.
Okay, yeah, my question 3 wouldn't be the same as yours. And can you give me the formula?
It says sec theta,
Okay,
then comma tan theta, and then a semicolon theta in quadrant 3.
and it says write the first in terms of the second.
Yeah,
Okay, write the first. That would be secant theta in secant theta terms the second. So, which would be tangent. Okay, there can be several ways to do this. Let's see. This is where I haven't shown people a whole lot of, we were showing basic stuff. I haven't really even shown this basic, I call it the grandfather formula. Grandmother formula, either one. That a sine squared, a cosine squared equals 1. Are you familiar with this, or should I explain even where that comes from?
I guess you can just explain a little bit of it, I guess, just so I know.
Okay, well, it really need for 5-4. Actually, they show you a lot of, well, not 5-4, I'm sorry, 5-3. They show this to you. Oh, they got to show it somewhere. Okay. They show it right here.
Okay.
Now, I call that the grandfather for that is the grand poobah of trigonometric formulas. If you want to know where it comes from, let's see if I can justify it. I don't know if you've watched any of my Zoom videos here, but remember you start with an x-axis, the y-axis. We're going to assume a unit circle. So you're swinging the radius around. Over here you'd have r equals 1. Anywhere you stop, you drop, and you have an x leg and a y leg, right?
Yeah.
And that's a Pythagorean theorem situation with the right triangle. X squared plus y squared equals 1 squared, right?
Yeah.
Okay, did we get across a sine of an angle is its opposite leg over the hypotenuse? This is opposite over hypotenuse. Have you seen those definitions before?
Oh yeah, like for sin, cos, and tan.
Right. Okay, this means that the sine of an angle is equal to the y coordinate. The sine of any angle as you swing around is equal to the y coordinate on a unit circle. If you play the game with cosine theta, its adjacent side is x over, again, 1, the hypotenuse. This is adjacent over hypotenuse. So the cosine of any angle is equal to the x coordinate around the circle. So if I plug these in for y and x, x is cosine theta, and then square it right up here. And then y is sine of theta squared equals 1. They usually switch it around. I don't know why they like to write the sine first. It's just maybe they imitate it the way it is on a calculator. You know, they always list sine first and then cosine second, even though sine's the y coordinate and cosine's the x coordinate. Yeah. So switch it around and you have sine squared of an angle, add the cosine squared of an angle equals 1. And that's where it comes from.
Oh, okay. Yeah.
Okay. To go further, again, we're zeroing in on what your original question was. To go further, you can divide through. I'll go to the next page. Okay. So we have sine plus cosine squared equals 1. Divide through by cosine squared. Cosine squared, cosine squared, cosine squared. Okay, let me talk about the simplest one first. That's this. Since these are equal, you get 1. Would you know that a sine divided by a cosine is a tangent? And since each is squared, it's a tangent squared? Or does that need explanation? Is this in your repertoire or does that need explanation?
What the tan square with the theta? Why dividing sin and cosine?
Sine theta divided by cosine theta is a tangent theta. You want an explanation of that?
Sure.
Well, back to the same diagram. X, y, theta. Remember, a tangent of an angle is opposite over adjacent. The opposite side is y.
Oh, okay.
The adjacent side is x. And on the previous page, we just said that y was sine theta and x was cosine theta. And if you square both sides, tan squared, then you square each of these, sine squared divided by cosine squared. They show all this to you in the book, same box. There it is. They can't show you every little variation, so they just show you the basic one, which is that tangent is a sine divided by cosine.
Yeah.
If you square both sides, then, you know, everything tan cubed is sine cubed over cosine cubed, you know. Whatever power it is, as long as it's the same on both sides, it'll be the same. These are called identities. You can, if one comes up, you can replace it with the other. Now, if you come over here, this is going to equal a secant squared. If you want an explanation of that, remember your cosine of theta was x. If I invert both sides, one over cosine theta equals 1 over x. It's going to get what I want. And 1 over cosine theta, if you remember, well, Why is it a secant? I could show you the list. All right. Remember sine theta was y. Remember these tables? I just showed you tangent theta was y over x. When you get the second column, 1 over sine, 1 over y, and that's a cosecant. Remember, when you get this other column, you invert these. Cosecant was the invert of these. Secant is the invert. So they're showing you this right here. A secant is 1 over cosine, a cosecant is 1 over sine, and a cotangent is 1 over tangent. You could do these from your basic opposite over hypotenuse. In other words, your cosecant is hypotenuse over opposite. So hypotenuse is 1 over opposite y, which is sine. This is hypotenuse over adjacent, whereas this is adjacent over hypotenuse. Your cotangent is x over y, if you want to see it completed. So if you believe this, we're just one step away from the answer on your original problem. I'll bring it down. This means secant squared. I'll write it 1 plus tangent squared. Take square root. Square root, and your secant is the square root of 1 plus your tangent squared. And you have expressed secant in terms of tangent. Hopefully that's the answer WebAssign is looking for.
So the square root of 1 plus 10 to the second of theta is the final answer for that one?
As far as I can, from their directions, express secant. That was the first one in terms of tangent, yes.
Cool. I also have a few more questions.
Sure thing. That's why I'm here.
Cool. This next one says find the values of the trigonometric functions of theta from the information given. And
This is WebAssign?
Yeah, 5.3.
Okay.
It
Find the
says,
values of the trig functions. And what's the given information?
CSC of theta equals 2, comma, theta in quadrant 1.
Theta in quadrant 1.
Yeah. And then it's when we have to list out like the sine, cosine, tan, sec.
Okay. So from what I just showed you on the previous page, you realize this means that sine theta is 1/2.
Oh yeah, I already knew that. That's what.
Do that. Okay. Quadrant 1. So that's going to give you a graph looking like this. Theta here. That's a right angle. Remember, this is opposite over hypotenuse. I would go ahead and just, you could put a 1/2 here and keep a 1, keep a unit circle, but I don't know. To me, it's kind of easier. I'll make this 1 the opposite and this the hypotenuse.
All right.
This means we got to find the x leg. So the x leg is going to be, or x leg squared, let's see, let me write out. X squared add 1 squared will equal 2 squared. So x squared plus 1 will equal 4. X will equal squared will equal 3. X would equal the square root of 3. Any questions about that?
No.
Okay, I'll go ahead and write the full table. Full table of trig values. Sine theta, it was already given, 1/2. If you want to do, you column, you actually what was given was 2. Cosine, that's adjacent over hypotenuse, so that's square root of 3 over 2. Tangent theta, opposite over adjacent, 1 over square root of 3. Any questions about that?
No, not yet.
Okay. The other two here, just flip them. Secant, 2 over square root of 3. Cotangent, square root of 3 over 1. I don't have to write it over 1. I'm not going to make you rationalize this. WebAssign might. I don't know if they do or not. If you did, it'd be square root of 3 over the square root of 3, and you'd get 2 square root of 3 over 3. Remember, square root of 3 times the square root of 3 cancels the root, gives you 3. Questions about that?
No.
Okay. Does this go in the category, it looks so easy when I do it?
Yeah, it's a lot more like, it's a lot more, I can kind of visualize it a lot better by having you write it down there.
Sure.
And I just have one more
Okay.
question on the other one. Let me find it real quick.
Sign.
I found one of them that I had trouble on.
What have you got?
It says find sine of A and cosine of B, and then comma tan of A and cot of B, comma, and then sec of A and CSC of B.
Okay, off those. Are they literally using A's and B's, or are they using this alpha symbol?
It's it's A and then it's like a B with the where the line's coming down on it.
So it looks like this.
Yeah.
Okay, does the A look like this?
No, it's just a regular A,
Small or capital?
small.
Small, okay. So I heard find sine of A, and then what of this?
And cosine of B,
Okay,
and then comma tan of A
okay.
and cot of B,
Cotangent B,
and then sec of A
okay.
and CSC of B.
Sounds like the full table, although they didn't ask for they didn't ask for cosine of A.
No, they didn't.
What's the picture?
It's a triangle with the angle A at the bottom left and B at the top right, and the bottom side is 20 and the side is 12.
Okay. Basically something like this.
Yeah, and it's 12 right next to the right angle. Yeah, right there.
Right here. So the two legs are 20 and 12.
Yeah.
Okay. So we're going to have to find your hypotenuse. C squared then would equal 20 squared add 12 squared. C squared would be 400 add 144. And that would be 544. I don't recall that that's a real clean roots. We need a
Yeah,
square root.
it's 23.32.
Okay. I I would just leave it like this rather than go to decimals.
Yeah.
So that's the square root of 544. And now you can just, by your basic definitions, a sine of A would be its opposite over hypotenuse, 12 over root 544. If you want to do them in the order they did them, cosine of the beta. Are we losing it? Are we losing you?
No.
So the beta's up here, that's its adjacent side would be 12 over the hypotenuse root 544. So they're actually the same thing.
So like for in the WebAssign here, it's sectioned off into like A, B, and C for the different answer choices. And so for the first one, it says sine A and cosine B. How would I write that into there?
Well, yeah, that's a good point. There's usually, did it say anything to directions about wanting decimal answers to certain places?
Nah, it just says find sine A, cosine B, and so on. And then it just shows the picture and it doesn't show anything about a rounding or anything like that.
Well, there's usually, if you look to the right of the screen, some sort of menu that allows you to enter square roots or something. In other words, math symbols, and square roots usually one of them.
Oh yeah. Oh yeah, I see that here.
Okay, now the only thing is, I don't know if it was programmed to accept the 544 or if they want it rationalized or if they want it simplified.
It isn't. I don't think it would ask. I don't think it's asking for that because it isn't. It doesn't say anything about with the decimal points and other just like the other questions we're asking. With the.
Okay. So I would try this first. If it doesn't work, we can try rationalizing it or simplifying the root 544. That's what drives me nuts about that darn program.
Yeah, it's
Right.
kind of.
Right. Try to guess what this makes me happy. You write this down, I'm happy. But trying to guess how they program the computer to make it happy is a bit of a pit.
Yeah.
Are we ready for the rest of them?
Oh yeah.
Okay. So your tangent A, that would be your opposite over adjacent, 12 over 20. Now, I don't know, WebAssign might like that. It might want it reduced. What goes into 2 goes into 4 goes into both. 4 into 12, 3. 4 into 20, 5 times. Okay, your cotangent of beta. Okay, that's true. Cotangents are tricky. All right, so you're up here. I always try to think tangent. I always try to think in terms of sine, cosine, and tangent, then flip them. So at beta here, your tangent be 20 over 12, which puts cotangent at 12 over 20. Same thing as tangent A.
Oh. Okay.
I guess that's the point of the problem, is to point out.
That is like similar.
Yeah, you can get very same values depending on where the angle is and whether you flip things. But yeah, the tangent A and cotangent of beta are going to be identical. Sine of A and cosine of beta, they're identical. My guess is these last two are identical too. No, I don't think they are. Secant and a cosec. Maybe they are. I got to write it down. Yeah. Are we ready for the last two?
Oh yeah.
Secant A. See, I'm thinking in terms of cosine. Now they didn't have me write cosine of A. So I'm going to be cosine of A would be the 20 over root 544. So the secant would be reversed, root 544 over 20. If you want me to write the cosine of A, which they didn't ask for, would be 20 over root 544. Adjacent over hypotenuse. So your secant flips it.
What about the CSC? What would that be?
Your cosecant of beta, All right, the sine on the beta would be 20 over this. Yeah, it's going to be identical. Root 544 over 20. Again, because the sine, if I want sine of beta, sine of the beta would be 20 over root 544. Sorry, this is sine beta. Be opposite beta over hypotenuse. So cosecant flips that. And yeah, these two do come out identical. Once you see it done, it's not that hard, but if you're not used to it, it does look like a lot of gibberish.
Pretty much. Let me see. I think I had one more question. That was all.
Sure thing.
It was for this question where it says to solve a right triangle, but it's
Okay.
I solved it out. What was that?
It's still off WebAssign?
Yeah, WebAssign 5.2.
Okay.
And it says find the other acute angle for
Okay.
solving a triangle problem.
What's it look like?
The hypotenuse is 38.5.
Okay.
And the angle on the bottom left is pi over 8.
Pi over 8. Okay. Solve a right triangle means pretty much find all the other legs and angles. Now, you sure they didn't give a leg?
Nah, that's all they gave me.
This is in WebAssign?
Yeah. I had solved it out here though. I found the legs and everything.
Okay, I'm not sure how you're on a blank.
I just used sine first. I did sine of pi over 8, and I did that equal.
Oh, okay, yeah, okay, y. I'll call that y this x. Okay, I get it, yeah. So you started with sine of pi over 8?
Yeah.
Okay,
I
yeah,
did
that'd be
equal.
opposite over 38.5.
Yeah.
Okay, multiply by 38.5. All right, and you can punch this directly, but you're going to want radian mode.
Oh yeah, I made sure to change that already.
Yeah, you got to really watch that in trig. There's degree mode and radian mode. And you got to make sure you're in the right mode or you'll get nonsensical numbers. It's a classic way to screw things up is not pay attention to what mode your calculator's in.
I was doing the test the other week, and that's what was happening with my calculator. I was so confused.
Right. So yeah, that's why it's important to look for the little circle degree symbol. If you see that, that's degree mode. If you don't see it, it's radian mode. So I don't screw it up myself. Let me check, and I am in radian mode. So it's simply a matter of punching 38.5 sine pi divided by 8. Easy punch. Just shame to screw it up if you're in the wrong mode. 14.73. And just one other point, they usually take your answers to the figures that are in the problem. So since they give us figures to the 10th place, we only need to write down answers to the 10th place. So I'm only going to write down 14.7 instead of say 7.3. All right, now there's actually a lot of different ways to proceed. We could play Pythagorean theorem. and solve for the x. You could do a cosine. Adjacent over hypotenuse. Again, multiply by 38.5. And I guess the most important general point is that you always get a y coordinate from a sine, even though you're not on a unit circle. If you put this into a circle, which you could, your radius on is 38.5. But you're getting your y coordinate from the sine, you're just scaling it by whatever your radius is, and you're getting an x coordinate from a cosine. So x is 38.5 cosine pi over 8. Cosine pi divided by 8. 35.57. I guess we'll round it up to 6. $35.6. All right, we call that theta. We find the other angle, and there's several ways you can do that. There's lots of different ways you could do that. Probably the easiest way is, remember all the angles add to 90 degrees?
Yeah.
Remember that? Could play it that way. In other words, pi over 8. And now I'm not going to use 90 degrees. I'm going to call that pi over 2 since this is in radians. Plus pi over 2 plus your theta. Have to add 180 degrees, and that's pi. This is my 90 degrees. This is my 180 degrees. But this keeps everything in the same system. Maybe the only disadvantage of this is that you have all these nasty fractions. You want them all on a common denominator of 8. So you got pi over 8, add 4 pi over 8. That would be pi over 2. In other words, I'm multiplying by 4, so top by 4. And over here, I'm multiplying by 8. Pi over 1 times 8 times 8. So that would be 8 pi over 8. Which is pi. Oh, plus theta. This would be 5 pi over 8, add theta equals 8 pi over 8. So can you tell your theta would be 3 pi over 8? You go minus 5 pi over 8, minus 5 pi over 8, you'd be at 3 pi over 8. You can kind of see it. 1 pi over 8 plus 3 pi over 8 is 4 pi over 8. There's your other 4 pi over 8, and you add up to pi. Now, is that too much gibberish doing it that way? Probably a lot more familiar doing it in degrees. You want to see another way, just to see if it might be easier?
Sure.
Well, you'd have to know that you're given this, given either one of, you can use either one of these. So if you want to use sine theta, this is kind of preview of the next section, next week. You'd have opposite 35 over hypotenuse 38.5, which is 35.6 over 38.5. You'd have sine theta equal to its opposite 35.6 over 38.5. And then you do an inverse sine. The functions up above a sine or cosine or tan. You see this minus 1? They undo it. Well, it's called taking the inverse sine. Inverse sine 35.6 over 38.5. So this undoes. And the answer comes out in whatever mode you're in, and we're in radian mode, so it's going to come out in decimal radians. I put second sine 35.6 divided by 38.5. It's come out 1.18 radians. If you want to double check it with this, 3 pi over 8 3 pi divided by 8, 1.178. So it's a lot of rounding on those tenths places. That give you any more confidence in it?
A little bit.
You'd have done an arc cosine if you'd used, it'd have been an arc cosine of a 14.7 over the 35.8. There's lots of different ways to do it. Any other questions?
Let me make sure. Let me scroll by, see if I have any. Oh, I have one more.
Yeah.
For this one, it says if theta equals pi over 3, find the value of each expression, and then lists out 2 expressions.
Okay.
It's sine parentheses 2 theta,
Okay.
and then after that, it's 6 sine theta.
6
Yeah,
sine theta.
yeah.
Okay. Can you give me a page number and problem number on this? Or is this still off WebAssign?
It's still off WebAssign, yeah.
WebAssign, okay. So you're going to put the pi over 3 in for the theta. So in here you get a sine of 2 pi over 3. Here you'll get 6 sine of pi over 3. Okay, now this is, to me, one of the fascinating things about trigonometry. At least it's fascinating to me. Okay. Turns out that the sine of 2 pi over 3 equals the sine of pi over 3. Rank amateurs might be looking at what? The 2 doesn't make any difference? So you need an explanation why this is the case? You can punch them and see. They'll give you the same decimal answer. I'll show you that. Sine 2 pi divided by 3 versus sine pi divided by 3. See, I get the same thing?
0.866.
Now, I'm guaranteeing or pretty much guessing WebAssign will not want those decimals. They're going to want the fractions. These are off the unit circle, and it will want fractions. But if you understand why these are exactly the same number, you understand a lot of trigonometry. So do you need an explanation of that?
No.
You get that?
Yeah.
All right. Well, probably to make WebAssign happy, we're going to have to use the fractions for these. So I do need the picture, and that will sort of explain why these are the same. When you go up to pi over 3, you're at 60 degrees. Okay. We mentioned these. I did a whole did a recording video. Your coordinates here are 1/2 and √3/2. This leg is √3/2, and this leg's 1/2. Do you need that explained, or do you remember why that is, or know why that is?
I got that part down.
Get that part down.
Yeah.
All right. So when you go to 2 pi over 3, you are at 60 degrees, or 1 more pi over 3 around. This angle is 2 pi over 3, which means you're at 60 degrees same reference. So these triangles are identical. I'm trying to draw them identical. These triangles are absolutely identical. It's just one's been reflected into the second quadrant, making its leg identical. Root 3 over 2, the x-coordinate is changed to -1/2. So this is equal to the sine of pi over 3. Because remember, the hypotenuse are 1. And this is equal to the sine of 2 pi over 3. They have exactly the same. You've doubled the angle, but that means you've just swung around. When you drop your vertical, you have exactly the same y leg at both angles. So the direct answer up here to make Webasine happy is root 3 over 2. Now over here, you're going to get root 3 over 2, but you're multiplying it by 6. I'll finish it down here. You're going to get 6 times root 3 over 2. 2 into 6 3 times. Looks like you get 3 root 3. My guess is Webasine is going to want these fractions, not their decimals. This is also equal to root 3 over 2, but times 6. Whereas this isn't multiplied by anything, it's just a directly root 3 over 2. You can double check this by getting the decimals. In other words, we're saying sine of 2 pi over 3 is root 3 over 2. I already punched the sine of 2 pi over 3 for you, got 0.866. Punch it directly as root 3 over 2. And there's your 0.866. All right. I've said that 6 sine of pi over 3 is equal to 6 times square root 3 over 2. I'll just punch it that way. Remember, we got, I'll punch it 6 sine pi over 3. That's 5.196. On the other side, 6 square root of 3 divided by 2, and you get the same thing. I don't know if that proved, which is 3 root 3. I don't know if that proved anything to anybody or to you or only to me. But did I add way too much gibberish to that?
Nah, not at all.
Okay. So bottom line, my guess is to make Webasine happy, you want this for that expression, and you want 3 root 3 for that expression. Any other questions?
This is the one that you went over, like in the beginning, about the secant tan in quadrant 3.
Okay.
I don't think I wrote down the answer. I wrote down all the notes and stuff, but I can't find the answer on my paper here. I just wanted to make sure.
Let me see if I can. Well, I think I got to a final answer on the next page, right down here at the bottom. This is what I've got for an answer, secant in terms of tangent.
Got it. I'm pretty sure that's it. I'm pretty sure you answered all the questions that I had.
Okay, well, very good. I've got a 9 o'clock Zoom meeting, so unless you got anything else, I'll go ahead and end this meeting, get ready for the 9 o'clock one. You got anything else then?
No, just thank you for coming here and helping me.
Absolutely. That's why I'm here. All right, we'll end this meeting, and we'll keep the same schedule of Zoom meetings for next week.
All right.
And appreciate you coming out real early on a Friday morning. Thank you very much.
No problem. Have a great day.
Same to you. Thank you.